So to install the VirtualBox, we'll go on to the website www.virtualbox.org. So this is owned by Oracle. So we can click on download and choose the suitable operating system and download the VirtualBox application. So I'm currently on Windows, so I'll be doing it on Windows. So as soon as your exe file gets downloaded, just run as administrator and install it. It will take several minutes to completely get installed. So we have successfully installed the latest version of VirtualBox, that is 7.1.6. Uh, you can see there are already two virtual machines created. One is Ubuntu of 32 bits and Kali Linux of 64. This is because I have already worked with virtual machines. So for this assignment, we'll create three virtual machines. To create an Ubuntu desktop virtual machine using VirtualBox, let's follow this tutorial by Ubuntu. So the overview goes, first we have to download the Ubuntu image. Then we have already installed the VirtualBox, so no, we can skip this step. So how to create a virtual machine? We have to click on the new button on the tab, mention the name, machine folder, and the ISO image, the path of the ISO image. Create a user profile, mention the username and the password. These are the default credentials. We can change it as well. So, okay. The main important thing is to define the virtual machine's resources. The hardware is about we in the section so it is recommended to provide a VM around 8 GB of RAM, although 4 GB will still be usable, and 4 CPUs. These are the recommended configurations. It also says that we have to try to remain in the green areas, a green shaded area of the slider to prevent any issues in the while running the virtual machine and the host OS. Also, setting up the virtual hard disk. Then for that, we are recommended to use around 25 GB as minimum, and by default the hard disk will be scaled dynamically as more memory is required up to the defined limit. We can also click on the checkbox, pre-allocate full size. This will improve the performance but may take unnecessary space. So the recommended is about to set the hard disk around 25 GB. After setting up the RAM, hardware, and the hard disk, we'll simply finish and initialize our machine. Finally, everything is installed. The installation is complete. Then and the machine will automatically reboot, and then you have to log in the virtual machine by the username and the password credentials that you have defined already while initializing the virtual machine. Later, you can just enjoy exploring the virtual box and the VM that you have created. Okay, so let's do it in practical. Let us begin by installing the ISO image of the OS. So I'm going for Ubuntu server instead of desktop. since I have only 20 GB hard disk left in my system. So I'll be going with Ubuntu server, so it will not have the GUI. It's about 2.6 GB, whereas for the desktop I would require about 5.8 GB. So we have two versions. This is the latest version, 24.1, including the 9 months of security and maintenance. Okay. Let's look into some features and choose which one would be suitable for our task. This is the LTS version. Okay, for now let's go with the smaller size one, 24.1. As soon as the ISO image gets downloaded, let's create the virtual machine. Click on the new button. Initialize the name of the virtual machine to say suppose VM1. Select the ISO image from the folder in your local machine, and the type, subtype, and the version of the guest OS or gets automatically selected. We can configure the username and the password as well. Uh, I'm setting the username of virtual machine 1 as VM1 itself. Give your suitable password. Next, moving on to the hardware resources. So it is recommended to keep the base memory or the RAM to about 2 GB to 4 GB. I am putting it to as 2 GB. Select the process number of processor CPUs you want. The suggested one lies between the range of 2 to 4. For my virtual machine 1, I'm setting it to as 2 CPUs. Setting up the hardware configuration. So the recommended range is from 5 to 8 GB. I'm for all my virtual machines, I am setting it to 5 GB. Check the file disk type as well, hard disk file type. That's to the disk image, which is right. This is the pre-allocate full size checkbox, which we would not do because we do not have much space. And then we'll click on finish. Let us simultaneously create other two virtual machines as well. So as soon as we start the VM, we get to choose the option try and install the Ubuntu server. So we have to click enter. After successfully installing the guest OS of all the virtual machines, let us work upon the most crucial part of the assignment. That is to make VMs, the multiple VMs, to communicate with each other. So as you can see, by default, the network has only one adapter, that is of NAT type. This NAT actually this is attached to the NAT, which provides the internet connection to the VMs, but does not enable any VM to VM communication. So for that, we have to change the network settings. Let's go on to the network settings of VM1. Now, you can see the adapter 1 tab is enabled and that is attached to NAT. Also, that the adapter 2 is disabled. We'll firstly enable this and set it to internal network configuration. And in network setting, configure adapter 1 to NAT. NAT will provide internet access, real-time network to like from the host OS to the guest OS.
and make sure that cable connected checkbox is checked. Now, also add adapter 2. For that, enable it as the network adapter first, then attach it to the internal network configuration. Choose the name of the network. Here it is intnet, and make sure that this mode is selected to either allow VMs or allow all. Allow VMs will only make sure that the network connection is on internal network is set among the VMs, whereas allow all would like it's the safe option to do. You can choose either of them would work for our assignment. Also make sure that it is cable connected. So we'll do this network configuration to all the VMs present. After that, we'll again start our VM. So let's start a VM. As soon as you start the VM, you have to log in into it by your username, enter your password, and later let us check IPA. So let us open. So username password. Okay, let's see its IPA. Okay, so here, yeah. So you can see here that my IPv4 address of ENP0S3 is 10.0.2.15. So what exactly is ENP0S3? So this represents our adapter 1 network settings that we are that is currently on NAT. That is to provide the network. Okay. So and what is ENP0S8? So this is for our adapter 2. We can see that currently it is down. And yeah, ENP0S3 is up in the up state. So and we can also see that there's no IP being assigned to the adapter 2. So for that we have to assign the adapter assign a static IP to each virtual machine also in the internal network. For that we have to change the network config YAML file. So for that we have to go into etc net plan, and there you will find the YAML file. So let's do it. Okay. So sudo nano etc-net plan date and the 50 the YAML file that's present. Enter the password. So this is the YAML network configuration of your VM. So you can see this version 2 is the default. We have to not change anything onto it. Then we have Ethernets, and we can see that ENP0S3 is mentioned, whereas ENP0S8 is not mentioned, since earlier in our VM we only had adapter 1 configured, and we have added adapter 2 into our network configurations. So for that we have to accordingly change the YAML file itself also. And here one more important thing is the DHCP4. So what is the role of this? This actually dynamically assigns the IP addresses to the nodes, virtual machines, etc. So for the network connection, CP4 should be true. The value should be true, and it works with NAT. So if NAT is present, DHCP should also be present. Now, so let's modify our YAML file. So let's do it quickly. So we have to add ENP0S8 also. So we'll do ENP0S8. Since this is internal network, we do not need DHCP. So for that, we'll mark it as no. Next is to allocate the IP address, static IP address to the VM. Hmm. So you can put it as 192.168. This is the range of IP address it should stay in. So 100.10 is for VM1 and we have allocated 100.11 to VM2. So let's allocate this as 1, 2 and here /24. So this 24 represents the number of bits we are taking to store the address. Okay. Uh, that will also be in the form of exponent, mantissa and power form. Okay, so we are done. We have allocated the static IP. Let's save this file. So for that, Control X and you modify it for saving it. Just click on Y and press enter. Now you're done with it. Now what we have to do is to apply this net plan. Okay, before applying, let's once again check what our IP address looks like. IPA looks like. Now you can see that still it is the same because we have not applied the net plan yet. So my adapter 2 is still down. Let's now apply my net plan, apply and press enter. We have applied it. Now let's again see our IPA. Now you can see my adapter 2 is up and it has an allocated IP that is the same value as we have assigned. So great, we have applied it. Now let's try pinging my other virtual machines through my virtual machine from this virtual machine. So let us okay. So I'll just simply, so this is my virtual machine 3. Let's ping virtual machine 1 from here. So my IP address of virtual machine 1 is 168.100.10. So this is my virtual machine. So I'm pinging it. See, now you can see the packets are being sent, being received from there, virtual machine 1. So great, we can stop this. Okay, let's ping our virtual machine 2 also. There's no issue in it. Just one, and we are done. Again, we are receiving packets from virtual machine 2 itself. It's great. The internal network is working absolutely fine. Okay. Now, also you can check that our network connection is proper or not by pinging any website. Say, suppose we'll ping Google. Let's do that and see as well. Great. So we are again receiving packets from there. So our network, our NAT is working absolutely fine, and as well as our internal network is set up absolutely fine. Now we have to move on to an other part of our assignment, that is to create a microservice. For creating a microservice, I'll be using Flask to create an API, a backend. Before that, um, let's go to our virtual machine 1. Have to first make our VM suitable. So this is our entire code that we have hosted from GitHub, hosted on GitHub. We have pushed the code on GitHub. Now we'll simply deploy the microservice application from GitHub repo. So before doing that, we'll simply do a sudo update and install the necessary libraries that we'll be using. So for that, sudo apt update, enter the password. It will take hardly 1 or 2 minutes. Okay, we enter sudo apt, install all the necessary IPs, necessary libraries that we require. We'll simply install them. Python 3. We also require pip, so we'll do that. We also require virtual environment, so we'll do that also. env and simply press enter. Currently, I have all these already installed, so I'll not go into this step, but you have to just simply enter this. So it says everything is already installed. Now we'll do move to our home directory and go to we have to clone our GitHub repo. So for that, you will just simply type git clone and the URL of the Git repo, GitHub repo. That will be like www.github.com, your username and the repo's name .git. So we'll simply do that and we'll be able to clone our uh, repo. So I have already done that and let's see our file. So that is in our directory multi-VM microservice. So we'll simply go inside the directory. Now, we have to we have already created a virtual environment there and installed all the requirements that we needed. For this, we only require Flask. So we can directly install that as well by doing pip install Flask, or you can initialize the environment and install the requirements there. All the requirements are listed in the requirements.txt file also. So we'll activate the virtual environment, Python Python source, source when activate. So we have activated our virtual environment. Now simply run the app present. Before that, we'll do Python 3 app and we'll run it. Now our backend server is actively running on our virtual machine 1. So you can see that it also mentions various IPs. So 127.0.01 and the port number that's 5000 it is using to run the service. Now, what is this IP? What is 127.0.01? We did not allocate it, right? And neither we saw that in adapter 1 or adapter two's IP address. So this is actually the local host. The local, you can type this in, you can ping this. This is, if you have to, if you want to call the API from virtual machine 1 itself, then you have to use this IP address to call the API to call any API request that you want to use. But if you want to call the API request from maybe virtual machine 2 or virtual machine 3, then you have to use the static IP address that we have used, that we have allocated for each of them, that is 192.6 168.100.10 11 or 12. Okay, and 10.0.2.1 is the network IP address that they have given. Okay, so now since you can see that this is running here, let's go to our virtual machine 2 and simply call, like, test our microservice or call some API request from there. So here you can see its IP address is 100.11. Now we'll do a get request. So for that, we'll type in curl enter the IP address. So for that, we'll do http colon slash slash 192.168.100 IP address of virtual machine 1. So that is 10. Enter the port number 5000 slash API slash task. So these are my endpoints of the API. So you can see that it has one task inside, that is sample task one. So, okay. So now we are able to get all the tasks that are listed in it. So let us try to make a post request on it. Okay. So for that, let's do curl x post request slash content type application dot slash JSON. Title. For the titles, I suppose I'll be writing multi VM connection. So, and close that. Okay. Multi this. Close the curly braces. Close the curly braces. Mention the IP address. HTTP colon slash slash 192.168.10. Enter the port number 5000. API and tasks endpoints. Press enter. Okay, my bad, there's an error. I have not entered the IP address properly. So I'll be 100.10. I think it should work. Yeah. So it would output the currently, and like the new task that we have created, it will post like it will show display that on the CLI. Now let's again do get all request and check if both of them appear or not. Yeah, so you can see both the tasks are now we are able to see with different IDs, that is ID1, ID2, sample task 1, multi VM connection. So great, we have achieved it. You can also try updating a new task. You can also try deleting it. The API works well with that as well. Um, Also, let's try doing calling the API from the virtual machine 1 itself. Let's see how it works. Okay, so virtual machine 1. So you can also see you're getting requests continuously from the virtual machine 1. Like, see, first you got the get request for the API for from the service backend service. Then you got post. Then you got get, and it also mentions from where, like which IP address it is giving. That is .11. That is our virtual machine 2. Mentioning the timestamp also, everything. So we have successfully completed our assignment. Well. So let's talk about our architecture diagram of the virtual machine that we have created. So let us understand the design very carefully. So, firstly, let the outer box be our host on which the virtual box is installed. So, inside the host itself, you have a network that is being created, that is the internal network, where there's a virtual switch that is connecting all the VMs that are lying on the network. And here I have created all three VMs with Ubuntu server image as ISO image as the guest OS, and have assigned various IPs uh, statically through the code. And you can ping any of these VMs or communicate between any of these VMs using these IP addresses. Now we have another section that is the NAT network, where the NAT provides the VM to connect to the network of the host OS. So, and host OS, that is through LAN. So, um, and also that the NAT provides communication of VM to host only. It is not bidirectional. Whereas in internal network, one virtual machine can send to another as well as receive from another. Hope the entire steps of this assignment make complete sense to you. I have tried answering every section of this assignment, small any every small problems that you may face while doing this task. So, see ya. Have a great day. Bye. Thank you.